Hello, everyone. My name is Matthew.
And my name is Bhavani.
We are both developer interns for Edge AI Innovations. Edge AI Innovations is a leading AI solutions company, and our current product is Moorcheh AI. Moorcheh AI is a lightning-fast search engine for vector databases. Using an API key, you can create namespaces, which are knowledge databases where you can store text documents or vector embeddings, and you can ask it queries to find the most relevant documents. Moorcheh AI offers 40% higher semantic accuracy, requires 32 times less memory, and requires 100 times less computation. Moorcheh's search engine is compatible with all embedding models, LLMs, and multimodal AI models. This makes it possible to use for different models and embeddings and seamlessly switch from one AI foundation model to another.
In this project, we built a Retrieval Augmented Generation accelerator that connects Moorcheh's AI vector search engine with Databricks' platform. We started by ingesting a sample dataset into Delta Lake, which served as a reliable storage layer. Using Spark, we processed and chunked the data documents into smaller, meaningful segments while extracting useful metadata. These chunks were then uploaded into Moorcheh's namespace, where they were embedded and indexed for high-speed semantic search. When a query is entered, Moorcheh returns the top matching chunks using efficient vector search. We then use those results to build a context-aware prompt and pass it into Databricks' LLM model, which generates a response based only on the retrieved content. By combining Delta Lake, Spark, Moorcheh, DBRX, and MLflow, we were able to demonstrate how powerful and modular a more modern RAG pipeline can be. Now we can go through the code. So firstly, as prerequisites, we installed the required packages and made all the necessary Python library imports, as seen here. Another important steps was setting up Moorcheh's configurations, which was done on the website where we generate an API key and API URL. We also did the same for Databricks' configuration, where we used the Llama model and the project configuration using UUID and unique suffixes. With this, we hard-coded sample data that was meant to simulate ingestion into Delta Lake, and we saved it to Delta Lake in a raw Delta table. After this, we chunked the documents into smaller pieces using word count-based chunking, used to simulate larger or more advanced strategies for chunking. As seen below, we saved those chunked pieces of data into a chunk delta table, which can be seen over here.
Next, we set up the text-based Moorcheh namespace, which is our knowledge database, which we store all our documents and vector embeddings. So with our Moorcheh API key and the URL and the namespace name, we create this namespace, and this will serve as sort of the container to hold all our documents where is the setting for which we ask queries to, and we'll provide the relevant documents. Yeah, so that's what we do first. Then we upload the chunk documents to the Moorcheh namespace. So we have all our documents and we divide them into chunks, and then we upload each chunk into the namespace for to be ready for the queries. And now for the section 5, we perform the semantic search query against Moorcheh. So here we ask Moorcheh our query uh, using the documents in that current namespace. And Moorcheh will use its relevant score system and provide the most relevant documents. And with this output, we will later feed this into an LLM model. So this is what we do in section 6. We build the RAG pipeline and we retrieve the output from Moorcheh and we input that into an LLM model. As previously discussed, we used the Llama model, and the Llama model will use that data to provide a more accurate answer to our query, as shown below. So based on the provided context, here's the answer to the user's query, and it describes Databricks platform and other things. And finally, we log and evaluate sort of the RAG pipeline with MLflow, and this basically kind of tracks all the important information from our process from our RAG pipeline. So we include the namespace name, the query, and the model, and other metrics that we use for analysis. And finally, we have a section for deleting the Moorcheh namespace, because sometimes we just have a temporary namespace to store our documents, and we exit the query and we're done with it. So this just helps us clean up the namespaces and sort of like clean up our place setting for Moorcheh.
This project gave us the opportunity to explore how modern AI tools can work together to build powerful systems. By combining Moorcheh's semantic search with Databricks, we were able to create a very successful functional RAG pipeline. We're grateful for this opportunity. Thank you for your time. We hope you enjoyed our demo.